Good afternoon and welcome to MAE 106, Lecture 4, Constructing Truth Tables. And this is the 4th of September, 14th. Good afternoon, everyone. So good thing, make sure that you say hi in the chat and also say if the audio is okay. Hello, hello, hello. And everyone is able to find the link. Good, excellent. Constructing truth tables. Excellent. Okay, so we're going to be constructing truth tables, and this is for compound propositions. And okay, so we remember that propositions were declarative statements that were either true or false, but not both. And we had things like prime and compound propositions. A prime was a single complete thought, whereas a compound had two or more ideas. And I think before we go, we should also remember from last time. Good. I like to see everyone. Hi. Excellent. So recall from last time, what we'll do is we'll go over all of the logical connectives that we did previously. So let's do the truth tables for it. We had P, Q, and I'll write not P, not Q. So this is P or Q. This is P and Q. There's the exclusive or. And there's the implication. And this is something that you will have to memorize. But if you remember kind of the rules, or just kind of the idea behind it, it shouldn't be too bad. So I have two propositions, and so this means I'm going to have four lines. And remember that P and Q are propositions. Okay. Now we have the negation over here for not P and not Q. So when we have not P, all this does is it flips the value of the truth value. So we go from T to F. So I have T to F, T to F, T to F, or sorry, from F to T, and F to T. Same thing over here with the Q's. Now I just work on this column right here. So this is T, F, T, F. Okay, so I go from T to F, F to T, T to F, and F to T. Okay. When we have the or, at least one of the propositions has to be true. So all I have to do is I look at these two right here. So as I go down, right here, TT, so that is true, because at least one of them is true. T and F, well, the P is true, so that's fine. The Q is true, so this is good. And I don't have any of them as true, so this is false. So there's that true table for that one. For the and, both of them have to be true. So starting again, here again, both of these are true, so this is true. And the rest are, both of them are not true. So we can easily fill that in as false, false, and false. With the exclusive or, this means that only one of the propositions is true for this to be true. So the only time that this happens is when I have the t and the f, so that's true here. And right here is f and t, so the q is true, so only one of them. And the rest, you know, this is false. And I can't have both of them to be true, so that's false as well. And lastly, we have the implication. Implication. And with that, again, thinking of your poison ivy idea, which is I stepped in poison ivy, I got a rash. So I stepped in poison ivy, I got a rash, that's true. I stepped in poison ivy and I didn't get a rash, that's not possible, so false. I didn't step in poison ivy, but I got a rash, this is true. You can have a rash from lots of things. And I didn't step in poison ivy and I didn't get a rash, that's true. So those are our logical connectives from last time. And that is what we covered in, I believe, section 1 point. I think that was 1.3. So if you aren't able to recall this or you missed this, go back to the previous, well, not right now because we're right now in lecture 4, but you can go back to lecture 3 and review that. Oh, and assignment 1 has been posted, so you can check that out on Moodle. So it's possible to construct more complicated or compound propositions. Oops. By using connectives. And we can also then construct from these truth tables for these more complicated or compound propositions. So what we're going to be kind of doing is just a whole string of examples to show you. It's like homework. Oh, sorry. Yes. When is it due? There is no due date. You should. Oh, okay. So again, there's no due date for the assignment. These are posted every week. So they're posted each week. And so you're expected to do them. And the solutions are at the back of the book. Okay. assignments are not handed in. So okay, and anything else I can say about the assignment? And if there's typos that you notice in the solutions, there is a forum that you can put that into in Moodle. It might be an error, it might not be an error. So if you're questioning it, feel free to post that in the Moodle forum. I think it says like typos, errors, and things at the top of the Moodle page. Okay, so let's construct something like this. So I have this very, the way that I would read this is the negation of P or Q. So we can, there's only two propositions in this. There's P and Q. Now, again, these are the prime propositions, and then this whole thing is the compound proposition. So I can do this in steps. So I look at the brackets inside here. I have the P or not Q, and then outside that is the negation. So I'm just going to construct it like this. So again, I start off by kind of enumerating all the possibilities that I can assign the truth values to P and Q. Now, I should know what the P or Q is, but if I look up here, I just can follow along here. So it's true, 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 and false. And then all I do now is I have a negation. I just take this and I flip the sign. So I'm working on this column now. So I have T becomes false, T becomes F, T becomes F, and F becomes T. So right there, this is the truth table. For that compound proposition, the negation of P or Q. Okay, so since this is a little bit of a longer lecture, I can actually get to take some time and allow you to take a moment and do this one now. I want you to do the negation of P and Q. I'll give you about 2 minutes, and then I'll write it out. So even if you're not relying on writing out all the notes during the lecture, what you should do is have some scrap paper nearby so that you can be doing some of the exercises while we're working on this. Okay, so there's about the 2 minutes, and this is what you should have got. So right here I have the P and Q. So it's true, false, false, false. And again, for the and, it has to be both true to be true. So this is the only case, and then the rest are false. And then to do the negation, we're flipping the truth values. So this becomes from T to F, F to T, F to T, F to T. Okay. Did everyone get what I got in this second answer? Okay, good. How complicated can these tables get? Yes, they can get very complicated. Yes, we're taking it slow. Okay, so then the next one we can do . So with this one, I have P, Q. And so again, I'm going to work with the inside of the bracket. There's P implies Q. So I have P implies Q, and then it's applying a negation to this. So that's my next step. And again, remembering our implication. So I stepped in poison ivy, I got a rash, that's true. I stepped in poison ivy, I didn't get a rash, that's not possible. I didn't step in poison ivy, I got a rash. Yes, you can get a rash from lots of things. And the last one, I didn't step in poison ivy and I didn't get a rash. Yes, this is possible. Okay, and then, so this is the implication, and then I just flip it with the negation. So T becomes F, F becomes T, T becomes F, and the last is F. Okay, so the next one I have is not P or Q. Okay, so what I'll do is I'll start off with my two prime propositions. I have P and Q, so start off with P, Q. And then the next thing I see is I have the not P. Well, we're going to work inside the brackets here. And just by the order of operations and working inside this brackets, I know that I have the not P, so that's what I'm going to need first. So the not P. Then the next I have the or, so it's the not P or Q. And then lastly, because I have the brackets now, I'm going to apply that negation to all of that. So then I have the not inside of it. So that's just kind of how I'm stepping through it. There's kind of like, I'll call this I. Let's see, how many colors do I got? The next one here, call this 2. And lastly, could this be simplified to P or not Q? P. I will get to that answer in a second. It might be. Oh yeah, sorry, I was doing the 3 here. So I'm just kind of stepping through it. So there's the first step, there's the second step, and there's the third step. So 1, 2, 3. So again, just writing out the prime propositions, all the possibilities. So in this first step, I'm going to negate the P, so F, T, T. Then, using this column and this column, I'm going to apply the OR. So I have, remember with the OR, at least one of them has to be true. Let me just cover up this part. So I have the not P or Q. So I'm looking at this one and this one. So it's either this one or this one has to be true. So there's at least one. So this is true. This one is, I don't have any. So that means that this is false. I have 2 true. So that's true. And I have at least 1. So this is true. Okay, and then the last one is, now that I have this one, I can now negate it. So I have false, true, false, false. So Mr. Val has asked, can this be simplified to P or not Q? So I will then take that as, I'll make that as our next example then. Let's look at this. Okay, so what I want is everyone to take a stab at this. Okay, so just take a minute, write that out yourself. I will write down the answer without a sight. Sorry, what was that? Sir, did you mean to change it to and? You mean right here? Did I mean to say that P and not Q? Oh. Okay. We'll do that one. Yes. I'll also put that one up here, so I'll do 6, sorry. So here's the 6. P or not Q. So we'll do this one as well. So again, I'm just going to flip this column. And then looking at this, so I'm looking at this column and this column. So true or false. So this is true, true, false, and true. So this is jumping just a little bit ahead, but Val had asked, can this be simplified to P or not Q? And to do that means to say that this is equivalent. And I know we're getting a little ahead of ourselves, but to be logically equivalent, you have to have the same truth table. So he says not P or Q. So I have false and here's true. No. This matches, but this one that matches and that doesn't match. So no, it's not the same. So just as the question. And the answer is no. They don't have the same, not the same truth table. Okay. However, if you'd finished doing number 5, so here, it's not the same. But if we looked at P and not Q, so I have here F, T, F, 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 T, F, F. So if I look at these, yes. So, you know, P and not Q is a simplification of this not P or Q. Okay, does that answer the question? Perfect. Okay. Yeah, there's a little bit of a lag. I think about 15 seconds. So if I'm not immediately answering, it's because I'm still, yeah, I haven't got the question yet. So, all right. What's the next one we could do? Let's do P or Q implies P implies Q. So same idea. What we'll do is we'll write out our prime propositions. We have P and Q. Well, I have two brackets here. So what I'll do is I'll look at kind of this one here and this one. So that's what I'll kind of look at the inside. So I'll have P or Q. And in the next column, I'll have P implies Q. And then lastly, I'll apply the implication to this column and this column to get our final answer. Okay. So again, you just have to write down your P or Q, and we know that it just has to have one of them to be true. The implication, again, just saying it to yourself. If I step in, or sorry, if I step in poison ivy, do I get a rash? Yes. I step in poison ivy and I didn't get a rash? No. I didn't step in poison ivy and I got a rash? Yes, that's possible. And I didn't step in poison ivy and I didn't get a rash? Yes, that's possible. And now I have these two columns that I'm going to be working with, and I apply the implication to these. So from this one and this one, I apply the implication. And this will get me this final answer. So I stepped in poison ivy and I got a rash. This is possible. I stepped in poison ivy and I didn't get a rash. This isn't possible. I stepped in poison ivy and I got a rash. This is true. I didn't step in poison ivy and I got a rash. This is still possible. Okay, so that would be our truth table for that. Okay, is there any questions with that? Okay. Taking notes helps a lot, yes. Yes, it does help. Okay, hopefully my connection is holding up. Good. Okay, what's the next one? Let's do, so that was example 8 we finished. Sorry, 7. Now moving on to 8. I have P and Q or R. Okay, so in this one I have 3 propositions. And I'm going to have 8 lines, because I'm going to have 2 to the 3, and that gives me 8. The reason for that is because I have 2 possibilities for assigning true or false, right, to the P, 2 possibilities for assigning it to Q, and 2 possibilities for assigning it to R. So 2 times 2 times 2 gives me 8. Okay, so working with the brackets, I'm going to have Q or R. And then the next step I'll have is applying the P to this inside the bracket. So I'll have P and Q or R. So I know I'm going to have 8 lines, or so I'm going to have 8 lines. So for the first one, I'm going to do half of those 8 are going to be true and half of those are going to be false. So I should have 4 trues and 4 falses. In the next one, I'm going to do half of them again. So instead of 4 trues, it's going to be 2 trues, and then we'll alternate. So true, true, false, false, true, true, false, false. And on the last one, we'll alternate again, so we half that again. So if we go from 2 to 1, so true, false, true, false, true, false. Okay. Okay, now, just with these 2 columns, I'm going to apply the OR. So I have, again, just one of them has to be true for it to be true. So cover up. So I have true and true, so this becomes true. There's at least one. There's at least one. Nope. So this is false. True, 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 and lastly false. Okay. And then what I should have done is have some cards so I can kind of cover up stuff. Here, let me cover up. So then for that part, this one, I'm going to be looking at these last 2. So I have the first one in this column that I'll be looking at, and I need to apply the and. That's what I need to do. So I'm applying this and, so between these 2 columns. So I have true and true, that's true. I have true and true, so that's true. So again, I'm just working my way down the list. True, and so this is false because both of them have to be true. And lastly, okay. So that is the truth table for that one. So now that I've done this one, you can do a very similar exercise for yourselves. Again, just pull out a piece of paper, or you can work through your notes. So try that one. Don't worry, I'll write out the solution. I'll just put this, let's kind of do it, hide it at a site for a little bit. So I'll give you 2 minutes to finish up that. So hopefully everyone's getting a hang of this. Okay, so this is the answer that I got. Basically, if you want to do a quick check, assuming that you've done your P, Q, and R the same way that I did it with the 4, 2, and 1 alternating, that you should have got 5 truths, and then the last 3 are falses. Is everyone doing okay with that? Did everyone get it? Or did I make a mistake? So far, okay, good. Okay. So far, good. Yeah, so the same idea. Just breaking it up, doing this one first because this is inside the parentheses, so there's your column right there. And so you would have been looking at doing your and again using these 2 columns to do the and. And then the next one would be using this column and this column to do the OR, and that's how you would get this final column. Okay. So doing truth tables, it's just practice. Let's throw in a negation. So let's do P or no Q. Let's do implies not R. Okay, so again, I have three propositions. So I start out P, Q, and R. Then the next thing that I see, I see the brackets, right? But I also see inside the brackets there's a negation. So I'm going to do that negation first. So the not R. Then I'll do outside the brackets here. So there's kind of my step here. I got this one right here. Then I'll do this here. And then I'll finally do this final one right here. So I have Q implies not R. Then I will do applying that P or Q implies not R. Okay, so I'm just going to talk through it again. If you want to work through this yourself, that's the great thing. You can just turn the volume down and then turn it back up when I'm almost done, so that you don't hear me kind of babbling. But oops. Do I have the correction tape? Come on, come on, come on, come on. Yes, I do. The only problem with the correction tape is that it does not work with this pen. So I have three propositions. I need to be there's 4 and there's 4. Okay, gives me 8 lines. And I can just flip this. So just flipping that, I go from T to F, and so it's just alternating. Okay, and then I need to apply Q to the not R. So I need a I'm going to cover it up with a thinner piece of paper. There we go. So to do that, I'll just cover that up right here. So I'm just doing the implication now to this. So maybe I'll cover up the P as well. There we go. So now I'm just applying the implication to these two rows. So I stepped in poison ivy. I didn't get a rash. That's not possible, so this is false. I stepped in poison ivy, I got a rash. Yep. Didn't step in it, I didn't get a rash. This is possible. I didn't step in it, I got a rash. Yes. I stepped in it, but I didn't get a rash. Nope. I stepped in it, I got a rash. True. And lastly, I didn't step in it, I got a rash. True. Okay. So we did the implication, applying it to the Q and the not R. Then I will apply the OR to these two columns. So I have P. Am I going to be able to try to do this with the ruler? There we go. And, okay, so for the OR, just one of them has to be true. So I have a true. So there it is. I have both of them. So that's true. This is true. Both of those are true. So that's true as well. Both of these are false. So, nope, that's false. One of them, there it is. That's the true. And lastly, true. Okay. So then the question is, did everyone get what I have here? 4 trues, then a false, and then the rest are true. Good. Can I make these more complicated? Excellent. That's good to see that everyone's getting it. And hopefully the people that turned off the sound is now back on, that they've checked. And there. Okay. So this is the one that we'll do. So first thing I notice is that there's only 2 prime propositions, so I'm going to write out as P and Q. I have 3 kind of terms that are in brackets. So what I'll do is this is the way I could, okay. I'll do the P implies Q. Then we'll do the not P. And then I'll do the, okay, so that will cover this term and this term. Then we'll have to do the and because it's inside the square bracket. Okay. So I've done this and this. I've done this bracket now. I'm going to then, now that I have the column for that, I'm going to do the implication with the not Q. And then that will be my last one. We'll be applying the implication to this column and this column. Okay. Okay, so I'll let you fill in that table, and I'll give you maybe about 3 or 4 minutes to do that, and then I'll write it out. If there's any questions, again, you can type in the chat. So just 3 minutes, see if you can do it. What is implication? The implication is what we did here. So there's the implication. This is the truth table that we did. What is implication? Poison ivy. Yes, that's the example that I was using for the implication. So just to do that really quickly. So the implication. And so I had been using it as the idea of P being like stepping in poison ivy, and then Q being a rash. And so it's that idea of that you have a cause and an effect. That you can still have the effect appearing without the cause being there. So you stepping in poison ivy and getting a rash, this is possible. You stepped in poison ivy, but you didn't get a rash. No, it's going to cause an irritant. And for poison ivy, okay, you didn't step in it, but you did get a rash. This is possible. You can get a rash from lots of things. And lastly, you didn't step in poison ivy and you didn't get a rash. This is possible. So this here is the implication truth table. And this was what we covered also in lecture 3, and it's in section 1.3 of the textbook. Sure. That's, again, an example of a cause and effect. Okay. So, it's a bit gruesome. However, if that's what helps you remember it, I won't stop you. Okay. Right, so with the implication, we had true, false, true, true. And with the negation, we just flip it. So I'm flipping the P, so I have false, false, true, true. And now I'm using these two columns to do the and. So that's false. Okay, I have the negation for this one, so I'm just flipping the values on this column. And then lastly, I apply the implication. So this is true. I stepped into poison ivy, I got a rash. Yes, that's true. I stepped in poison ivy and I didn't get a rash. That's false. And then I stepped in poison ivy, I got a rash. That's true. So I got true, true, false, true. Is that what people got? I hope so. I hope I did it right. Yes, perfect. Cool. So that's basically constructing truth tables for compound propositions. And again, you can just, it keeps getting bigger and bigger. And so just try doing some of the questions from the homework. And that should be in section 1.4. Okay, so the next section in the book is section 1.6 that we'll cover. There's 1.5, I know, but that's something that we don't cover, which is switching circuits. So we'll move on to 1.6, which is tautologies and contradictions. And so the definition of a tautology. Okay, so it's a proposition. Okay, so it's a proposition. Remember, a proposition is either true or false. It's a proposition, but in this case, it's true under all possible truth assignments. And in our book, it's denoted by a T. This is what we call blackboard T. Blackboard notation, because we just kind of double it up. And okay, so I've told you what this is, but you're kind of like, what do you mean true under all possible truth assignments? Well, let me just give you the example. Here's the proposition P or not P. So I write, I can do a truth table for this. I only have one prime proposition, so it's P or not P. Then over here I have the P or not P. Okay. I have true or false. And then this just flips. So I go from false to true. And the next one I have is doing the or. Again, one of them has to just be true. So that's true, and this is true. So this is true. P or not P is true under all possible truth assignments. So right here, you know, that's what we call a tautology, because it's true. So therefore, P or not P is a tautology. Okay, page. So we've done a tautology. Now we'll do a contradiction. So to be or not to be is a tautology, yes. Yes, it is. So yes, it's a tautology. Contradiction. Contradiction. So we have a contradiction. So again, it's a proposition. And in this case, it's false. Under all possible truth assignments. And we denote this with, again, a blackboard F. And so I can do my example. This one would be to be and not to be. Okay, so I have P and not P, so there's true and false and true. And so when I do the and, both of them have to be true for it to be true. So I have true and false, that's false. I have false and true, that's false. So again, it's false, this proposition P and not P. So I'm going to make sure that I write in maybe something like, here's the and. So that this is false under all the possible truth assignments to this. So because of the truth table, therefore, P and not P, or to be and not to be, is a contradiction. Okay, and then the last case, we have, okay, so we've done where it's true under all possible truth assignments. It's false under all possible truth assignments. Then the last case is like, it's neither. It's neither all true and nor all false. And that's what we call a contingency. So that's a proposition. Neither a tautology nor a contradiction. There is nothing to denote this. So an example of this can be anything where all the columns were not all true or false. So right here, 11 here, we look at this, there's at least one false, so this is not a tautology. This is a contingency. Same thing with this one. This isn't all true or all false. That this is also a contingency. This is a contingency as well. This is a contingency. Again, contingency, contingency, and so on. So there's lots of examples of contingencies. I can even we'll just write out the implication again. So again, just to keep it complete in our notes. Okay. So a tautology is where it's all true. A contradiction is where it's all false, and then the contingency is where it's neither tautology nor contradiction. Okay, so this is exercise. Let's say exercise 1.6.2. And it's show that the following are tautologies by using a truth table. Okay. I have P and not P implies Q. So I have two prime propositions here. So I'll do P, Q. Then I'll work inside with the brackets here. I have the P. I see an and here as well. So, or sorry, the negation here. So I'll do the negation. Then I'll do the P and not P. And then lastly, I'll do the P and not P implies Q. Okay. Just writing out my usual enumeration of truth values for P and Q. Okay, then the next thing I know, I got P and not P. So, sorry, I just have to flip. So I have the not P. So I flip the value. So I go F, T, T. Now we've already done this one, P and not P, so we already know that this is a contradiction. So I can just write all F's. Right, so that's false. And then the next thing I have to do is do the implication with Q. So I need to use now remember, I'm going from this column to this column. So maybe, just to make sure that people understand that it's really important with the implication, the order does matter. I will write the Q over on this side as well. So I'll just copy that out. It's really important which direction, because again, it's an arrow. It's the direction matters. So I'll just copy these out. Just over there. And then I can do the implication. So I'm going from, okay, I didn't step in poison ivy, but I got a rash. This is possible. I stepped in poison ivy. I didn't step in poison ivy and I didn't get a rash. This is possible. I didn't step in poison ivy. I got a rash. Yes, this is possible. And lastly, I didn't step in poison ivy and I didn't get a rash. This is possible. So at the last one, I have T, 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 T. So this is a tautology. So since all the truth or the Therefore, that proposition is a tautology. So that's kind of the nice thing. When you get a question like this, say on a test or something, where it says show that something is a tautology, immediately you should be expecting that all the final truth values should be all t's. Okay, so with this one I have, here's another one. So I have P, not P, then I'll have P and not P, and lastly P and not P. And so already what you should be thinking is that I know from our previous exercise, or our example, where we had this, P and not P, this is a contradiction, where those are all falses. So all inside right here should be all falses, and then applying that negation should convert those all to true. So intuitively, we should expect this to be a tautology. And so if we do the work, we in fact do see that this is a tautology. So the last one in that exercise, so here's page 7. So what I have here is I have not P implies P implies P. Again, I have to show that this is a tautology. So I have just one prime proposition, so I just have P. Then I'll have a not P. And then looking inside here, inside the brackets here, I'll do the not P implies P. And then lastly, I'll do that last one. So all that. So again, be very careful about the direction of the arrow that's going. So it's going from this column to this column. So I stepped in poison ivy, I got a rash, this is true. I stepped in poison ivy and I didn't get a rash, this is false. Okay. I'm just checking, yep. And then the next thing is I take this column and I apply it to P. So I stepped in poison ivy, I got a rash, this is true. I didn't step in poison ivy, I didn't get a rash, this is true. Therefore, not P implies P implies P is a tautology. Okay. How about something like this? So that's the end of that exercise. So here's the question: is a tautology implies not no, let's not do that. Let's do something. Let's do is a contradiction P implies R. A tautology. So what we do is I have two prime propositions. So I have P, R, and then I also can think of it, here's kind of F. So I have true, true, false, false. I have true, false, true, false. With a contradiction, it's always going to be false. So now I'll do the P implies R. So that's just our standard implication table. So I have T and T, that's T. This is false, true, and true. And now I apply the implication to this column and this column. So I have the implication applied to I have false implies true. Okay, so this is true. I just didn't step in poison ivy. I didn't get a rash. This is true. I didn't step in poison ivy. I got a rash. This is true. And the last one is well, it's the same one. That's a tautology. So therefore, a contradiction implying P implies R is a tautology. Could I make this a little bit simpler? Is a tautology, is a contradiction imply something always a tautology? Well, we can think of it as, let's just do F implies P. So you'll have P and let me just do F over here. So I'll have false, false. And over here I have my P, which is true or false. And doing my implication, I get false implies true. So I didn't step in I didn't step in poison ivy, but I got a rash. This is true. And I didn't step in poison ivy, but I didn't get a rash. This is also true. So this is a tautology. So the answer, well, again, it depends. If you can simplify this down so that it's just a contradiction implies a proposition, then yes, it's going to be a tautology. So that's what we really have done. You can just take this P implies R and think of it as a proposition. It is. It's just a compound proposition. And so if you know if it's always going to be a contradiction at the beginning, it doesn't matter what the truth values are then for this proposition that follows it, it's always going to be true. Okay. Then what I should get, let's do one more. So this is just another exercise. So here's my proposition. I have P or not Q, and Q or not P, tautology. So is this okay? I just want to make sure. So is the connection okay so far? On the internet, is the video smooth or is it kind of glitchy? I'm just doing a connection check. Okay, perfect. Yeah, it's just jumping a little bit on my screen, so I was just wondering. Okay. So, is that a tautology? So, I want you to take 3 or 4 minutes, and I want you to do that one. And don't worry, I will do this. I'll just write it below here, and then we'll take it up. But this time, I'm not going to write out the headers of the table. I just want you to try it and see what you get. Okay. So move that up. So this is what I got for my solution. I got true, false, false, true. Did everyone match with that? Yes, good. Somebody's remarking, memorizing what the symbols mean is a lot easier when you have to do a lot of questions with them. Yep. Yes. It's practice. It's a lot of practice. Yes. Okay, good. So how am I doing this? Now you might have your order of different columns in different places, and that's okay as long as you got the same answer as this, and that basically everything kind of breaks down similar. But you know, the order in which these columns appear is not necessarily the definitive order that you need to write them down. But as I was just kind of reading across, I saw this one. So here's the I. And then I saw this one in here. So that's what I did here. That's my second column. I noticed in here. That's the one over here. Over here I have 1, 4. So now and lastly, oh, I'm running out of colors. Here's my 5. And I'm going to put a circle around these so that people don't think that that last one, the 5, is an or. So problem solved. 5. Okay. So if you got the same ones, just breaking it down but column by column, in the end over here, it's not a tautology, and it's not contradiction. So to answer the top question up here, again, we have to always be answering what the question was asking us in the first place. So therefore, P or not Q, and Q or not P is not a tautology. So, like someone has pointed out, the key to this is memorizing and practicing with those logical connectives. And breaking down those logical, those compound propositions into, let's say, bite size pieces. That's what we're doing here. We have something that's quite big and like it looks complicated, but if we break it down into little chunks, into these little columns, and in a way that we can take one column or another and apply an operation, like applying that logical connective to it, it makes it quite straightforward. When you start to do too many steps at once in one column, there is a chance, or you might be prone to creating an error. Okay, so perfect. Okay, so again, try some of the questions from assignment 1. They don't take a super long time to do. And don't, if you feel that you're running out of time, pick a couple, 10-15 minutes. And then if you feel comfortable, again, just practice enough. Once you do them, it starts to become more routine. And it's a skill, and it's a skill that you need to practice, and trying to practice a skill night before you're going to be examined on it is not advisable. So again, practice makes perfect. Is there any more questions before we sign off for today, or for tonight? If you have any questions, feel free to send me an email. The other thing is I'll probably be setting up some office hours. We'll do this over Zoom, so it's not in a public forum such as YouTube. So maybe I'll just make a little note of that. To be announced. This will be conducted over Zoom. Okay. But to just kind of clarify, make sure when you do come to the office hours or doing Zoom, make sure you have questions or something where you are a little bit if you there's a concept that you're not quite sure about, but don't ask questions like, can you teach me lecture 3 again? There's a video for that. You can watch that. So, use the office hours for something like that's more tailored to your needs. So, or a question that you weren't comfortable to ask during the lecture. Okay. If there isn't any more questions, I'll just sign off for today. Thank you everyone for participating. Thank you for doing the exercises along with me, and I'll see you tomorrow. Good night.